Hi, so we're going to look at squares and square roots today. Most of y'all are probably familiar with squaring a number. That's where you multiply the number by itself. You're not multiplying by 2, you have to multiply the number by itself. So for example, 3 squared would be 9 and not 6. Well, a square root is the exact opposite. What you're looking for is what number times itself will give you that square root number. So let's look at the definition. It says here that a square root is one of two equal factors of a number's. For example, the square root of 25 is 5, because 5 times 5, or 5 squared, is 25. Since negative 5 times negative 5 is also 25, negative 5 is also the square root of 25. We're not going to really talk much about the negative part of it right now, but just know in the back of your mind that a square root number can actually be a positive or a negative, because when you multiply a negative times a negative, you still get that positive number. Okay, let's keep looking here at these at the box, because it's going to really get into the radical sign. And what the radical sign is, it is the symbol for square root, and I'm going to circle it. It's this symbol right there. That's called the radical sign. That is the symbol for square root, indicating what is the square root of it. So if you notice here, here's where we say the square root of 25 equals 5. Numbers like 25, 49, 64 are called perfect squares because their non-negative square roots are whole numbers. If you think about it, the square root of 25 would be 5, the square root of 49 would be 7, and the square root of 64 would be 8. Those are all perfect squares. Numbers that are not perfect squares do not have whole numbers for their square roots. And what we're going to look at here in just a second in example B is how to handle that, how to work with numbers that are not perfect squares. So let's look at this first one here. For example, A, it says to find the square root of 64. So in my mind, I'm trying to think what number times itself is 64. Well, the square root of 64 would be 8. Notice I didn't do any division. This isn't a division type of problem. This is simply what number times itself will give me that perfect square. So this one would be 8. My answer would be 8. All right, example B. Find the best integer that estimates for the square root of 44. The square root of 44 is not a perfect square. There is no number times itself that would give me 44. So here's what I'm going to think about. I'm going to see where 44 does lie in my perfect square sequence. So I'm going to try to think about my perfect squares. And I'm trying to think the numbers around 44. Well, I know 6 times 6 is 36, and that's pretty close to 44. So I'm going to write down 36 over here. That's 6 times 6. Well, 7 times 7 is 49. So if you notice, the number I'm looking for, 44, lies in between 36 and 49. So let's think. The square root of 36 is 6. And the square root of 49 is 7. So my answer lies between 6 and 7. And we're not going to have to estimate exactly what it is, but what I want us to do is to circle the one that it's closer to. Well, let's think. Is 44 closer to 36 or 49? That's right, it's closer to 49, so I'm going to just circle that 7. And that's what we're going to look for in those kinds of problems. Now, like I said at the beginning, this is not a problem dealing with division. In fact, the best way to handle square roots is by memorizing as many of them as you can. The more that you have in your memory, the much easier this lesson is. So here I've listed a chart of the squares from 1 to 30. You by no means have to learn all of these, but the more that you can know, the easier it is. For example, I hope that y'all already know numbers 1 through 10. Those should be already in your memory bank. Those should not be very hard to study. So now what I would try to do is I would now try to study the second column, okay, 11 through 20. Try to get those in your memory bank. And then once you get those done, then move on to 21 through 30. The more that you know, the easier this is. Try to go back and memorize as many of these as you can. I think that will be really helpful. And good luck, y'all will do great at this. Get into some examples. So on numbers 1 through 6, We're going to find the square root of all of these numbers. So the square root of 16, what number times itself is 16? Well, that would be 4. 4 times 4 is 16. Now I'm looking for the square root of 36, and we'll talk about that negative sign at the outside of it in just a second. Let's just worry about the square root of 36. The square root of 36 would be 6. Since there's a negative on the outside, we just bring it down in our answer. On number 3, it's the exact opposite here. The square root of 36 is 6, and this time there is no negative sign, so I don't even have to worry about that. What number times itself is 121? That would be 11. 11 times 11 is 121. Now we're getting into some higher numbers now. So here's where, if you're not sure, you can go over to the side and actually multiply them out. But if you have them memorized, you're good to go. For example, the square root of 225 is 15, and that's a part of that second column I was talking about if you can try to remember. And then this last one, the square root of 900. The square root of 900 would be 30. 30 times 30 is 900. And since there's that negative sign, I just bring it straight down. All right, on these last ones, we are here to do, and we're not going to use when it says to then check with the calculator. I'm going to actually cross that out. We're not going to do that. What we're going to do is we're going to pick the two numbers it's closest to and circle the one that it is absolutely closest to. So the square root of 45. Well, we had an example very similar to that. 45 would be in between 36 and 49. Those are my other two perfect squares. And which one is it closer to? Well, it's closer to 49. So my square root of these two numbers is 6 and 7, and it's closer to 7. Let's do 29. So the perfect squares it's in between would be 5 times 5, which is 25, and 6 times 6, which would be 36. So the square root would be 5 and 6. And it would be closer to 5 because 29 is closer to 25 than it is to 36. All right, the square root of 5. Well, let's think. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So those are my two perfect squares. It's in between, so it's going to be in between 2 and 3, and it's going to be closer to 2 because 5 is closer to 4. All right, now is where we're getting into some bigger numbers here. So let's think about what these could be closest to. So 640, well, I know that 25 times 25 is 625. And I know that 26 times 26 is 676. And again, this is just from me doing these over and over again. The more that you do, the better that you'll get. The more you have memorized, the better that you'll get there. And so now we're looking to see which one would that be closest to. And before I do that, let me go ahead and say that this square root is 25 and this square root is 26. And so now we're looking to see which one would it be closest to. And if I'm doing my math correctly, it would be closer to the 25. All right, we've got 250 now. So I'm trying to think what number times itself is closest to 250. Well, we've got 225, and that is the square root is 15. And then the square root of 16 would be 256. And that number lies in between, and it is closer to 256. Oh, and it does have a negative, so I'm just going to bring down those negatives along with it. All right, and then this last one. So I'm thinking, what would this lie between? Well, it would lie between 49 and 64 there. And the square root of 49 is 7, and the square root of 64 is 8. And so now I'm trying to think which one would this be closer to, and it is a little bit closer to 64. So this is how we're going to work on these problems. We're just trying to get our brain used to dealing with square roots. Try to go back. Let me go